It's my pleasure to announce the first guest speaker of the day, Rod Wilson. He's travelled halfway around the world to be with us today, so thank you, Rod. And thank you to Ciena and One New Zealand who have sponsored Rod's attendance today. Rod Wilson serves as Chief Technologist, External Research Networks, where he is responsible for Ciena's leadership and global interactions with universities, government programs, and national research and education networks. Rod, I welcome you to the stage and look forward to your presentation on practical advice for conducting experimental research.
Well, hello and good morning. It's a pleasure to be here. It's wonderful to be here with all of you. And it's also wonderful to take a break from the cold Canadian winter that's raging at home. My wife's hometown over the weekend had 2.5 meters of snow. And it's minus 15 at home, so a pleasant day in Ottawa. So this is spectacular. It's a pleasure to be with you today. The talk is actually some practical experience, and I'm going to give some advice based on over 20 years of working with research and education networks and the users of these networks, the applications that push the envelope. Now, the word on this slide is experiment, and it's a rather odd word to put up in front of a room full of researchers. You know, it's a noun, it's a verb, it's a directive. Sometimes it's an excuse. You know, well, that didn't work at all. Well, mate, well, it was kind of an experiment, right? So it's a theme that'll run through this talk, because a lot of the experiences that we've done through collaboration and partnership have been based on a spirit of experimentation. And through some of the examples, I hope to draw out the practical learnings we've had from collaboration with research scientists in a number of different academic fields, not just the electronics and photonics of optical infrastructure. But before I do that, I should explain a little bit about who Ciena is and what we do. So Ciena is a networking systems company. We provide services and software that create the circulatory system for the internet. We have over 1,800 customers worldwide. Those customers are a mixture of enterprises, service providers, advanced cloud services providers, and hyperscalers. 87% of the world's infrastructure companies use our services. So if you enjoy that internet thing, there's a pretty good, better than even chance that your packet has somewhere passed through Ciena equipment. But we're not a household name. We're buried very deep in the infrastructure, which is actually quite esoteric. We have over 8,000 employees. We operate in over 130 different countries. We like to think of our products and services as adaptive networks that are able to change to meet the changing conditions that different use cases throw at a network. And this is very important when we start thinking about research networks. So the ability to have automation and software control of the network, to have some of the artificial intelligence so that we can be more predictive about the performance of the network, and then have a truly programmable infrastructure. And this is our stock and trade. This is what we do all around the world with Ciena services to back it up. Now, what's actually driving the company are kind of the global trends that most people are familiar with, and there are no surprises on this slide. But if you're investing research and development money in creating products, you have to be very sensitive to these market pressures. So obviously the cloudification of everything, the data centers that are becoming larger, faster, more powerful, hopefully greener, certainly safer in terms of their cybersecurity as well as their resiliency. Internet of Things, well, my favorite example is my Bluetooth connected toothbrush. So it will actually give me, biometric feedback on how well I'm brushing my teeth, and it'll record the history over time, and I can play back the history of you get it, right? It's hyper-connected everything. And when I'm talking to my political friends at home in the province of Ontario, they said, well, so what's, why is the large capacity backbone company like Ciena interested in Internet of Things, the little things that happen at the edge of the network? And I said, well, you don't understand. There are 4.7 million households in the province of Ontario. And I say, well, how many IP addresses do you have at home? Well, the eyes roll. They give them a little tutorial on what an IP address is. Okay. Then we come back to it and say, so it's not hard to imagine, a couple of dozen connected devices in your home, each with an IP address, Internet Protocol address. Pretty easy to. I actually counted my home, but I'm not typical. I have over 40 IP addresses that are more or less running off. But I'm kind of weird. But it's not hard to imagine by the time you put your doorbells and toothbrushes and everything else on 100 things, right? So 100 attached Internet of Things, and all that junk turns on. What do you think happens to the backbone? It's sort of like when you check into a cheap hotel and you get connected to the Wi-Fi, but you're not really connected to the Ethernet, right? The little spinning. Do you want to do that to the province's economy? Okay, now I have your attention. Internet of Things is one of the fundamental drivers of the way things are going. There are other aspects, of course, 5G wireless for Ciena. Wireless backhaul is a huge part of our business. The bottom of every one of those cell towers is a fiber. We light that stuff up, and we provide that as a product. Similarly with submarine systems, which of course are fundamental to the New Zealand economy and fundamental to research sharing and collaboration on a global scale. And broadband access and these other technologies are really driving our business and really shaping the future of telecommunications technology. If I bring it back to the users and our customers, there's actually a common service challenge that has emerged. And this is really infrastructure platforms. So we're all looking for personalized cloud services. The ability to connect whatever your particular field of interest is, whether it's education or retail, manufacturing, design. Those are all served by a number of different cloud capabilities, and the cloud vendors are ubiquitous, growing, and of increasing importance to global economies. So what's required, of course, is personalized service. The service that makes the network, the connectivity, the distance disappear so that we can all use these services in ways that are meaningful to us. So that's a common challenge right across the industry and plays a big role in how we develop services for our products and technologies. So that's really the thumbnail sketch of Ciena. And I'm not going to actually talk about Ciena solutions other than how we've applied it in research networks. But before I go there, I should say a word about what my group does. So I have a team of researchers, engineers, and business people that work in our Chief Technology Office group, or CTO group as it's called. And we're responsible for external research. So kind of simply put, I describe this as a sensor network, where we have lots of sensors out in the real world, finding out trends, looking at different things that are going on, to perform almost like a lighthouse function, separate from our business activities. Internally, when I'm talking to colleagues, they say, "Oh, the CTO group, what do you do?" Well, we're not developers. We don't actually develop any products or features, or we don't do design work. Oh, okay. And we're not in sales. We don't do marketing. We don't sort of represent a face to how we commercialize our technologies, and we don't do that either. Well, Ciena as a company, the entire company is designed around people who build products and people who sell products. And so we're this mixed bag of kind of misfits in the middle. So why in heaven's name are you still here? You look like a rather expensive group. Our role is actually to investigate promising new technologies, to be out working in emerging areas, to look beyond our product trajectories. And if you speak to a Ciena developer or one of our marketing people, they know exactly what's going to happen for the next 30 months. They have release schedules and they know which features, and maybe some puts and takes as you go. But once you get on beyond 3 years, then it's kind of like, okay, go. So we look beyond our product trajectories to try and anticipate things that will be beneficial for the company, the proverbial canaries in the mine shaft. And we usually say, come along, this is great, follow us. We've found a new emerging technology. Let's create a program or a seed around it. Sometimes we say, whoa, bad road ahead. do not come this way. There was a time when lots of companies do this. Of course, everyone wants to engage in the future and understand what the technology futures look like and how you have to shift your weight or pivot. Rather than a think tank, we like to think of ourselves as a do tank. So we create activities in collaboration with the community through experimentation, through trials, through support of universities and university-based research. The fundamental characteristic of everyone who has a science degree and has pursued science is curiosity. It's a really interesting discussion. It's to say, well, I'm a very passionate engineer. I know quite a bit about photonic system design, Ethernet. I'm very curious about that. But scientists are curious in their chosen fields. And so if you adopt an attitude of curiosity, then that drives you into places where you never imagined you could go. And that's very exciting. So we pathfind, we engage, and we engage subject matter experts. And those experts help us unlock the future. Or in some cases, really look at how technology gets delivered. So this CTO group that I described really is in a mission to explore new technologies, kind of qualify them. Are they any good? Do they have any merit? And then if they do have merit, transition them. So the technology development process is this, it comes from an idea. Not unlike science. There's some innovation that takes place, some intellectual property, the development of protocols and prototypes, production, and through to end of life. The actual development components behind these products begin with research, in our case, external research, because we want to engage the community on promising new technologies. We test those ideas. The ones that have promise, we actually create a prototype, or we use the university in partnership to create the prototype, and then we give the researchers an opportunity to stand and really leverage what they've done. And then if that's promising, we have this transition activities where we do rapid develop prototypes, and then we work with our product development people to actually incubate a new product and go through and develop it. In there's also a business case. The coolest technology on the planet may not be the one that has any business success. And then we manage those products as one would do. So to talk a little bit about the framework of the CTO group and our external mission, we explore emerging technologies, next generation network technologies, and solutions and architectures. We do that with leading external researchers and universities, and we contribute insights on how to achieve strategic and business success in the future. We do it through scanning technology 3 to 5 years out, so that's our horizon. We monitor the silences. Is there a space there where we can go? Try and avoid the surprises, which are almost impossible in this business. We generate new ideas, intellectual property. We try and enhance Ciena's leadership position, and we try and gain some R&D efficiencies. If we're able to explore a technology, it saves our developers from deviating from their task, which is to build the next generation world-class products. So we research. When we engage in research, collaborative projects, we gain some R&D efficiencies, but one of the things that we also gain is awareness. So benefit for Ciena is to be included as a co-author, to participate in the research project. So we view ourselves as researchers, as people engaged in looking at these products shoulder to shoulder with the students, and I have a couple of examples coming up of some excellent student research. And the outcomes are really how we leverage this. We look at how to invest in emerging new technologies. We look at really how to explore and develop further the commercial benefits from this stuff. So that's my kind of lay of the land. That's my level set of where Ciena is coming from. A little bit about what our motivation is behind this, because it is somewhat different from many other companies in industry. But at this point, for the next few minutes, I'm going to look at experience that we've had from some from history. So I have a couple of examples of kind of high water marks over the past more than 20 years, things that have changed direction in industry or changed direction for telecommunications. I'll give you some examples of work that we're doing right now. So some of the things that we're investing in, some of the projects that we've undertaken with universities around the world. And lastly, some future stuff, things that are emerging technologies. We're just making those very first initial seed investments and looking for collaborators or just getting our feet wet. And along the way, because this talk is supposed to be practical advice, there are a couple of points that I'll share as we've gone on this journey. So that's kind of the setup. Let's look at some historic case studies. So set your Wayback Machine to 1997. Okay, the emerging technology, the technology of the day was asynchronous transfer mode, ATM, not the cash point, but actually ATM. It had some unique characteristics in that the throughput of the network was completely deterministic, which means that if you were handling phone calls or video calls or things like that, things would be very nicely sequenced. You could have very precise timing and delivery. It was going to be the big thing. And to explore this, we collaborated with a huge group of people, not the least of which was the U.S. government, which has a program called the Defense Advanced Research Program Administration, or DARPA. And DARPA set up a program called NTON, which was the Network Technologies Optical Network. And so NTON sponsored a whole bunch of work, a whole bunch of research for a wide variety of different players. Some of them were universities, some of them were the energy physics labs in the United States. Other vendors like Uniphase and Rockwell, Hughes, Pacific Bell, Pac Bell, the carrier, Columbia University. So it was a really interesting sort of mixed bag of nuts to work on these emerging technologies. And everybody had their own area of specialization. Ciena at the time, our predecessor in this time was Nortel Networks. I am a previous employee of Nortel. But how do you put this together? What's the stage that you use to put a proof of concept like how do you do the demo? So there have been for over 25 years a conference in the United States called Supercomputing, or SC. And there's been an SCXX since the early 1990s. So in 1997, we went to the Supercomputer Conference, And one of the features of this conference is obviously supercomputers, so big iron guys, IBM and Silicon Graphics and AMD and all the typical large high-performance computers, but also high-performance networking. It's sort of where high-performance computers meet high-performance networking. And so to do that, there's this amazing testbed network that's not just like across the show floor, but it's global, it's international. And so they commandeer facilities through research and education networks, much like RANS here and others around the world, to create an infrastructure that allows this stuff to actually work. Now, in our case, so we did a demonstration. In this case, we were using video because video needs that very predictable deterministic flows. So across the bottom here, there was a whole bunch of different video things that we did, and we were able to shift this stuff around, and the video was delivered. And this is decades before Netflix. So this was like really cool stuff. So it was a huge success. So that's my first example. It was Enton. The program wrapped up in the mid-2000s with a lot of reports, a lot of academic success, but a lot of engineering success too. It was an absolutely amazing pathfinding exercise for all the participants, and in fact for all of industry. So skip forward to 2006. One of my colleagues, Franco Travestino, was looking at machine migration, like how to migrate not just the operating system, which was possible, but actually to migrate the machine. And so we set up a network that connected the supercompute conference that year, CO6, I think it was in, it moves around every year. I think that was to Portland or Seattle. Set up this network. We had the wide area network, so we had light paths between, Tampa, it says Tampa, Amsterdam, and South Korea. So the network was there. And so what we wanted to do was take a live system that was showing a movie in Tampa, discover a network path, provision it, move the operating system while the movie is playing over to a mirror site, continue playing the movie, and just for fun, move it again, let's try South Korea, and then bring it back to Tampa. So no mean feat. But how do you tell the story? So we said, okay, well, we'll pretend that it's in a data center, and the data center goes overheat, right? So the temperature threshold exceeds, and so the network says, software control, let's save the operation. So we actually got a little thermal sensor so that we could simulate, because we didn't have a data center, we had a laptop, right? So we need to simulate that over. So we stole borrowed a hairdryer from the hotel, and we had a little thermal sensor, and we kind of put on the sensor, and it overheated. At least that was enough to tell the laptop, start your thing. And so it did the discovery, and it migrated the system. You're watching the movie, and amazingly, there's not even a flicker. It was so perfectly synchronized. It took 70 seconds to discover the route, do an active live migration, and move the operating system literally around the world. So that was in 2006 and was absolutely groundbreaking work at the time. This was before VMware was trying to simply do the operating system migration. In terms of networking research papers for the participants and co-authors, was the most cited paper of its type since then. It's still pulled off from research sites as groundbreaking work. So the sensor, CPU, data, virtualization, and control, which we called the virtual machine turntable. And absolutely amazing work and really quite special. There was an organization called the Global Lambda Interchange Facility, and this was a collaborative group made up of research and education networks around the world. And they primarily they wanted to know how to work together, right? If a researcher in New Zealand wanted to connect to a researcher in Europe, how would you stitch that service together? You would reach out to Rayance, and they'd have peering arrangements, and how do you actually engineer that in a more seamless and better way? So in 2014, this Glyph organization actually had their meeting here in Queenstown, which was in New Zealand, in Queenstown, which was kind of cool. And we said, let's do a demo. Let's connect the Ridges Hotel, the ski resort, in Queenstown to, I don't know, let's say Chicago. Through collaboration with 1NZ and their predecessor Vodafone, local cable carrier, Southern Cross, we were able to connect the hotel room, a room much like this, to California. And then once we were in California, we were able to get a circuit up to Chicago, which is one of the big research network hubs. Now, the problem was that none of the Glyph people thought this would work. Like that, like if you phone up your local carrier and you say, "Hi, I'd like a new internet drop here at home." Yeah, I'm not downtown, but I need it like next week. I'm only going to use it for about 2 or 3 hours, and I'd like it for free. Yeah, it just doesn't happen, right? It's like, we did it, but nobody believed we could do it, so there was no demo. And then the guys from the U.S. Naval Research Academy, they said, well, we can come up with a demo. And I was still kind of desperate because we've called in all our favors and we worked with our buddies and we got this amazing facility. Who remembers buying their first video camera, right? And you got home and you kind of plugged it into your TV and you did this. And you saw it back. Hey, it works. This is great. That's our demo. Perfect. So we'll do a loop back from California. We'll get our camera. We'll shoot it into the fiber. It'll go all the way to California and come back, and then you'll see it on the screen. Oh, and we'll encrypt it, and we'll measure latency and stuff like that. So at least we had something to show, and that worked fine. The Naval Research guys did a much more compelling video. They touched on a health issue of melanoma and cancer. And so they actually had a physician in the audience, and they had a patient, a volunteer, in Australia. And they said, it was in, and so there was a diagnosis, and the professor, the physician, the woman had a regular mole on her cheek. Has it changed color? Has it changed thickness? I think you're fine. I don't think it's melanoma, but I'm going to call in a colleague of mine who's an expert. And up on the screen pops a skin cancer researcher at Northwestern University in Chicago. And the image was in 4K, and it's as clear as we are in this room. Now, 4K at the time was just emerging as commercial capabilities, but to use it for long-distance telemedicine was something that people hadn't seen before. And that happened right here in New Zealand for the first time. And it received quite a bit of press attention. And the last one from my history files is actually a project called the Secure Autonomous Research Network. It was done in partnership with the University of Amsterdam. This is the video created by the students. But the whole gist of this was if you had a network and it was under DDoS attack, denial of service attack, are the things that you could do to automatically mitigate this. And we know it's a huge commercial problem right now. It's a huge threat. And so we created a network, a real testbed network, and we were able to put it under attack. So we turned on the servers. There was actually a little meter at the bottom. Bear with me, right? So there's a little meter at the bottom that instead of kind of bits per second or throughput was actually showing dollars, right? So pretend it's a commercial network, right? So the attack begins. And the network's, happily working along. All the little packets are going chink, chink, chink through the network. The dollars are counting, boing, boing, boing. DDoS attack starts. And of course, the performance of the network drops to nil. The little money counter goes to 0. And so what was created was the ability to automatically detect that, which is not too hard, but you obviously need the analytics to do it. And then you figure out what can you do about it. Now, you can't just turn off the DDoS because it's distributed. You don't know where it's from. But you can change some of the network operating parameters, perhaps reduce speed, filter some protocols, and restore the service using those techniques. What we wanted to do was use AI, and so it would happen in an autonomous way. And so this is what we set up, what was created. But even more than that, we created a honeypot so that the DDoS would all go to a server, would collect the addresses for later analysis and future blacklisting. And so the program was very successful. We also looked at some password brute force testing. And so this was a precursor for a lot of the network automation around cybersecurity that's rolled out today. And the students did a fantastic job, and you can tell from the video, they had a lot of fun. There was fun in the front end and a lot of very serious research in the back end. So the practical advice part. Remember I said that the talk was about practical advice? There's this wonderful advice column from Northwestern University, and it sort of goes out to industry and says, so you want to work with a researcher. Here's what, you can hire a researcher to write code for you, or explore different algorithms. There's a whole bunch of advice here. It's not bad advice, but it's not our approach. So when you're working with an industry partner, check their motivation. Because are they interested in kind of exploring and being curious and experimenting, or do they need coders to develop their products? Both are valid. In my case, we're very proud of our developers, and if they need extra help, they just hire them. If I find good students, they'll hire those students. But we use our collaboration with universities. Our motivation is actually to float all boats a little bit higher. Many of our projects, many of our demonstrations work with our competitors. Drives my marketing people cuckoo, but we really enjoy looking at multi-vendor environments. That's what's driving the world. That's what's real. Okay, so let's talk a little bit about our current collaboration, some of the things that we're doing today. So I mentioned supercomputing. This is still a going concern. It's a very successful conference. There are over 10,000 attendees. There are over 200 exhibitors. And there's still this testbed network called Ciena. So Ciena is this global reach. The big picture in the middle is actually the on-show floor infrastructure. But the total bandwidth leaving the convention center this year was 4.7 terabits per second. So that's a huge amount of data. And so there are a bunch of researchers from some of the universities and the NASA people and the NOAA people, some friends from the Large Hadron Collider and Caltech, the real world Big Bang Theory guys. Let's flood the network. Let's break the... We want a data tsunami to see what would happen, and we'll measure everything in metro. It's fantastic. So they're actually able to put forward demonstrations that used much of this bandwidth, and it connected across the world, typically to research universities that have a booth or a presence at supercomputing, and the network itself is accomplished. Over many months of planning. There were over 175 volunteers and literally dozens of vendors. And this is my example of kind of, maybe it's somewhat altruistic, right? Vendors, because this is so cool, vendors are kind of able to check their competitive egos at the door and come in with a relatively collegiate attitude. And so, yes, I'd like to know more about how the Nokia system works, but that's just through experiential learning. That's not any kind of industrial espionage. We're working together to achieve this. And so supercomputing is a great platform for research demonstrations. Our students and our interns often develop a project, a demonstration. They work for a whole year on it, sometimes more than a year. And if it's really good, we send them to supercomputing and say, okay, now you're going to talk to the real world. You're going to engage industry like you never have before. And we'll give them, we have a typical trade show booth, as you can see in the bottom corner there. We turn a portion of that booth over to our research students. Let them do the demonstration. And so, sure, we're there to have a commercial representation, but for us in the CTO group, it's more about having fun and experimenting and using this tremendous appliance called Ciena. The problem with Ciena is it lasts for 4 days. So there's this huge, Herculean effort to set up this whiz-band network, and when the show's over, it's done. So we created a testbed network, which we call the Ciena Environment for Network Innovation, which is a direct ripoff from a United States National Science Foundation project called Genie, but we have a Ciena. It is a testbed network that the footprint goes from Ottawa to Chicago, Chicago to New York City, New York City to McLean, Virginia, then back to Montreal and back to Ottawa, so we have a loop. There's a leg that goes to Europe, landing in the Netherlight R&E Exchange. There's a leg that goes to Indiana University, and there's a leg that goes to the Utah State Telehealth and Education Network, UETN. The center hub for this is Starlight, which is in Chicago. It is the world's largest research and education network gigapop. There are over 200 networks that flow through this facility, which is really cool. The first time I was there, I was getting a tour, and there was like this control room with all these monitors and guys working with, well, this is amazing. That's the cable TV network for the students. Our stuff's over here in the back room, right? So Starlight's a great partner, headed by Dr. Joe Mambretti and Dr. Jim Chen, and they do world-class stuff at the Center for International Advanced Internet Research. So, but the advantage for this is it's like on demand. So if a partner like Internet2 or university researcher needs to have an infrastructure to play with that's outside Ciena's firewall, it's completely exposed, as are all R&E networks, at least to that limit. We create an environment that actually lets people explore technologies 365 days a year. And Ciena uses it a bit too, but it's mostly an appliance for our collaborators. Also, most recently was the Data Mover Challenge, which is hosted by the National Supercomputing Center of Singapore. Every 2 years, they kind of put out a challenge. At the surface level, it's what I call photon cannons, right? So 2 servers exchange data at maximum speed. But they kind of muck with the middle. So they put in a bunch of parameters about restricted flows, circuit failures, different bandwidths, different speeds. And so they create a very complex operating environment and then want to explore how you use artificial intelligence, network provisioning, and advanced control mechanisms to actually gain maximum throughput. This year, just to throw in an extra wrinkle, they said, please include some satellite downlinks. We know that they're not high speed, but it's reality. A lot of the world is serviced through satellite services, so please include that in your demonstration. So the winners are going to be announced next week at the Supercompute Asia conference in Sydney. My team had a credible, well, our team, which included Northwestern University, University of Osaka, Japan, UETN, and some other contributors. So we had a submission, and we'll find out how we did next week. That practical part again, because that is the point of this presentation. Remember that your community researchers actually have a great deal of power and clout. You know things that nobody else knows. you can facilitate conversations that industry would not otherwise have. You can create some stretch objectives, and you get to ask for things. So don't underestimate the clout that you have. For a successful project, it has to be attractive, though. You have to create a people gravitational pull. My entire career, I've only ever had regular, fairly small teams in terms of direct employees, but project teams of hundreds. And that's really easy to do if everyone buys off on the vision. People will move heaven and earth if they believe in the vision and want to be part of that club and want to be part of that team. I guess it's my retribution for being the nerdy kid in the high school cafeteria that no. We want to create virtual teams that have everyone, even the cool kids, want to come. Having done that, let's have an air of forgiveness. These kinds of things have to be a safe place to fail. It has to have sort of a no harm, no foul characteristic to it, or industry will shy away. I don't want to damage commercial future of my company with a not quite ready for prime time technology. What I need is that kind of flair of experimentation as an excuse. That didn't work at all, mate. Well, it was an experiment, right? And then these things, some professors, some schools, it's like an annuity, right? They get on with industry, and it kind of goes year after year after year. We like that. We like to have a deadline, a focus, something that's going to pique the interest, pique the mind, and bring people to power and produce great things. So that's practical advice number 2. We're making future right now. So the last part of my presentation will actually look at some of the technologies that we're on, projects that we're working on today. So the other conference for industry, for certainly in our industry, the Optical Technology Conference, is hosted by the IEEE Communications Society, the Photonics Society, and Optica, which is the American Optical Organization. They have a huge conference, over 15,000 attendees, which in the world of optical technologies is a big show. There's 6 days of workshops, mini courses, lots of papers, over 850 exhibitors. But most of these exhibitors were doing optical waveguides. Like they'd have like a jewelry store counter with lots of little quartz lights on it and kind of golden connectors and please, sign a big deal. So a lot of kind of component vendors, a lot of optical technologies that were used in making networks, but there was no opportunity to actually talk about networks and zero opportunity to actually have a live demonstration network. And so working with a group of industry and R&E people, we've been able to create a demonstration network for optical technology, which we call OFCnet. And OFCnet is, last year was kind of our pilot year. We were able to create a demo facility, both for on the show floor as well as some external connectivity, not on the scale of SciNet, but very much around emerging optical technologies. And so coming up next month, there are 25 academic and industry demonstrations. 9 of them, more than half of them, or almost half of them, are on quantum technologies, quantum key distribution, quantum entanglement, and some of the quantum physics around networking. There are a couple of emerging companies that are very significant. ITQ, Idée Quantique, and Nucrypt are companies that are actually able to generate quantum keys. There are also other groups there. The Open ROADM standard is actually an ability to mix and match between different vendors. Normally, vendors sort of have proprietary modem stuff. You can only talk to them. Well, the world of optics is becoming a lot more standardized, but the systems behind those are not so much. And so the Open ROADM Optical Communications Group has a series of demonstrations to show interoperability. The lead demonstrator for that is NTT from Japan. CESNET is the Research and Education Network of the Czech Republic. Northwestern University iCare and University of Texas are there, as well as NEC and Enritsu. So an interesting combination of industry and academics showing new openness in networks. There's also government involvement. The National Science Foundation has a project called Fabric, which is looking at network operating systems. There's a Japanese-led initiative called ION, which deals with the future of optical networks, like 10, 15, 20 years out. And CzechLight is the research consortium associated with the Czech Republic. And so if they were going to do this other demo, they may as well get the government brothers in there as well, right? A project that we're doing in our own group, we're doing it in collaboration with one of the universities in Montreal, Concordia University, as well as one of the undergraduate colleges, Dawson College CEGEP in Montreal. The vision for the project is actually a self-optimizing fabric, but the definition of fabric here is probably much more familiar to people in this room than it is for networking people. When you talk to a networking person about fabric, they're usually talking about the interconnection of devices, right? You know, DW, ADM, MUX to MUX, or, you know, modem to modem, or router to router. But in this case, the fabric is a fabric of all resources: storage, compute, cloud, all the resources that one might want to provision in a network. One of the observations is that the way networks are provisioned today typically have like a central control mechanism, you know, like a big computer, and the computer goes and learns about who's on the network, and they bring back that information, and they do an analysis, and the operator says, provision me this, and it creates a network connection. If a network connection fails, it goes back to the central control. The central control says, alarm, alarm, alarm. If it's really good, it'll say reroute, reroute, reroute. If not, it'll just say alarm, alarm until somebody takes action, right? But what we want to do is use AI to actually understand how to optimize the fabric for flows, for failures, and work around this. The observation, our observation of this centralized control doesn't scale into the future. At some point, the box isn't going to be big enough or smart enough, or the connections are going to be complex enough, particularly if you're looking at all resources, that this kind of fragmented, manual system, human-assisted thing isn't going to work. And so we have a vision that really looks at how to self-optimize all these resources, create much more of a peer environment. And that's what we've done. We've created the Intelligent Distributed Fabric Engine, or IDFE. And it actually creates a shim that sits on all resources, that can discover and share and dynamically peer discover each other and optimize the flow. So it's a research project. It is challenging. It's challenging our students. It's a very novel use of artificial intelligence, and is really pushing the envelope. And when I speak to my colleagues, particularly my network management colleagues inside Ciena, I say, you know, your approach to network management, you're headed full speed into a brick wall. You're going to smack that wall, and it's really going to hurt. But I can't tell you when that wall is there. So we're going to explore these technologies, explore these methods, and if we discover tools or techniques, we'll spin that off so you can incorporate it into your products in the future if it makes sense. In the meantime, we're using this as an exploration vehicle to test the limits of how networks are provisioned and managed. Another program that we're working on really deals with spatial computing and immersive environments. So this is kind of cool. I mean, it's kind of a metaverse experience. We think it's the future of how people will interface with their computers. So give me a grain of salt on this. So we're right back to 1840, the patent for the typewriter, right? And so for you know, a great deal of time, decades, we would all interface with a keyboard, right? Clickety, 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 right? We replaced that with word processors, keyboard, bzz, 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 right? But same keyboard. And then we got very smart. We said, well, let's have a mouse, right? So we could move around the page a little bit. The computing was wonderful, right? We're still interfacing with the keyboard, and we now have a mouse. Then we got into tactile mice or touchpads, like I have on my. Fast forward a little bit more. We have tactile feedback. If you have some manufacturers of earbuds create spatial environments. We've had gaming headsets and augmented vision for a while. But we really see that there's going to be a broad shift in the way people interact with their technologies. I really find it much easier to dictate a text message than trying to, well, with these sausages, you know. Anyway, so there's a whole suite of emerging technologies here that are pretty interesting. I was in San Diego with a startup company, and they were creating an immersive environment. So it was about half the size of this room, and had standard office T-bar ceiling with transducers, with transceivers, and we got outfitted with our headset with a funky antenna on the back, and put into an environment. The environment I chose was the airport tarmac at LAX, and so you're sitting there and you're looking at these giant planes. Oh, this is so cool. And you know, when you're at the airport and you kind of look out the window, there's a little roadway down there with all little baggage trucks going back and forth, pulling their little carousel, right? Here comes one now. And I step into the traffic as this thing approaches. And the test is, so what physiological reaction do you have when that happens? I braced for the hit. Oh, so cool. Now, so we can do that now, and if you have a PlayStation, you can go off and do this stuff. The interesting thing, of course, is how these images are rendered. So the more photorealistic it is, the deeper the rendering. You need a really cool rendering computer. Now, we're a room full of people, but pretend they're just two, or maybe just the three or four at your table. You're all looking at the same thing. Maybe you're looking at me, maybe you're looking at the slide. But however many people there are at the table, they're different perspectives, right? Everybody has a slightly different angle on what they're seeing. And by the way, you might be gazing off into somewhere, who knows. But, so the challenge for rendering computers to support multiple people in the same environment is a whole new field of computer science or spatial computing in immersive environments. It's super cool, and I want to play. But I'm a networking guy, so please tell me, right? There are a number of things that need for this to happen, particularly if we start looking at how to do it at distance. So very high bandwidth. 5G for sure, wireless connectivity. 6G is the next iteration, which looks more at industrial applications than end user. Obviously, edge computing. Artificial intelligence only makes this work better. Intelligent networks, this adaptive network that I was. So this whole thing is really a networking exercise in the future. And so we're putting a little bit of effort into exploring this. We have a partnership with a company in Quebec called OVA. And OVA is, they're not a startup, but they're a young company. And they've created a immersive environment. Their first client is the Royal Canadian Navy. So as it turns out, it costs the Navy $100,000 a day to float a boat with a bunch of recruits to go figure out how to move around on the deck of the ship, right? And this is how they do it, right? Your tax dollars at work. Good defense training is always a good investment. But OVA said, well, look, we can virtualize that whole thing. So they did. So they created the deck of a ship, and they can train as many recruits in a classroom as you can fit for $10,000. Full stop, one payment. And so they got the business. Now they're working at other environments, being able to recreate environments using blueprints. So if you think of firefighters being able to have an immersive experience, training experience, being able to know how it is to move in a building when you can't otherwise see. So it's a very exciting field. Now, if you don't think this is happening, that's the Apple Provision that was announced last June. It's now shipping in the United States and rolling out worldwide. This is a spatial computer. It's not just Google Glasses. It's not just a virtual environment. This is a visual computer with multiple screens and full spatial experience. It's right now it's kind of large. There's a battery. It's kind of heavy. It costs nearly $4,000. But just watch, right? It's going to get lighter, smarter, faster, much easier to power. The last technology I'll talk about before I get to my final lessons learned is really quantum technologies. I kind of make fun of this because every university on the planet that has a physics department now has a quantum program, right? You can sign up for your quantum. If it's a big university, they have a quantum institute, and you can sign up for your program. There's a great deal of government research going on behind quantum entanglement, how to move qubits, or at least simulate qubit, what is called entangled communications. There's a great deal of work being done on quantum computing, and of course what's spinning up is more quantum networking. And I'm certainly not an expert. I read a great deal. I had a lovely textbook on quantum networking. I threw it out over Christmas because it was like a year and a half old, so it's obsolete. And I didn't understand what it was talking about. I certainly couldn't do the math. So I it's a bit of it's my favorite book. It's actually How the Hippies Saved Physics, which talks about a couple of Berkeley students that went back to some of the debates in the early 1920s, before the world got completely absorbed in nuclear physics, and really started to explore some of these early quantum techniques. And so it's a read that I could understand. You know, there was coffee involved. There may or not have been hallucinogenics, but there was some really, really good exploratory stuff, and it's a great book, and I enjoyed it. But what is practical and what is real with us right now is quantum key distribution. And one of the principles behind quantum communications is if you observe, if you break a chain, the chain dissolves. It no longer functions. And so if you can use quantum principles to share encryption keys, the keys are secure. If you change them every second or so, it creates an encoded message channel that is extremely secure, arguably unbreakable. So this is available today. There are a number of products on the market that do it. I'm certainly not going to give a QKD tutorial here, but it is a technology that is currently commercially available and is being deployed and is using these early quantum distribution, quantum key techniques to secure data flows. So wrapping up with the last of my practical advice, for us, it's more than an in-kind investment. It's more than a cash investment. It's an investment of our people. We assign a principal investigator, just like any other research project that works hand in hand with an academic PI as we explore things. The results are often readouts, seminars, discussions like that. We love it when we get interns. So interns and graduate students and postdocs to work on interesting products, environments. For researchers, they get access to industry and industry expertise. Ciena spends over $500 million every year on advanced telecommunications R&D. Would you like to know what we're working on? Would you like to come and play with some of it? Those are the environments that help lift the research community. And we like to use, test beds as a kind of network research accelerator. We believe, and my practice for my entire career has been that rising tides float all boats. And all of our research, almost all of our research is done in the open and is shared on public test beds, shared with other researchers, and in the spirit of open research, open collaborative research. Things like intellectual property, yeah, we'll squirrel that off. We'll try and develop it. But IP often takes decades before it becomes real, particularly if you're doing good research. And so there is a practical advice collaboration checklist. The takeaway from this is that it has to be a trusted environment. You can write all the paper you can want, you can sign all the non-disclosure agreements, but if you don't have a trusted environment, then all this is kind of pointless. We like to experience outcomes. We want that spirit of collaboration, really to have a statement of research and deliver to a plan. We like these collaborative environments and demonstrations. We like conference presentations that reference Ciena. But really the bottom line is people. This is a grad student that worked on the WaveLogic 6 Extreme chip, which is a modem that Ciena developed. But yeah, forget the IC and the little circuit board. Look at this guy's face. You know, this is a proud fellow who's achieved something early in his career that he might never otherwise have. And so the last slide really is experiment with an exclamation mark. Hopefully through my chat this morning, you've seen the spirit of experimentation, the spirit of working openly with industry on really cool stuff. Thank you very much.
Firstly, before I thank you, is there any questions? Because we do have about a few minutes, just quick questions. Any hands? No. Okay. So, oh, there is. Oh, there is. Yes.
Networks. Is there research that you do into more sustainable metals or recycling? Do you have that kind of?
Yeah, absolutely. It's not an area that I picked out for this presentation, but certainly the greening of networks is a huge challenge. As we increase the density and power of the circuit packs that we build, if we put more and more hundreds of gigs into a pizza box, we have to at the same time do research on how to reduce the power consumption and the throughput. The guy who was holding the chip there, that WaveLogic 5 chip, was amazing. It was a 17% increase in spectral efficiency, so all my optical buddies go, ooh. But all the other people are blown away by the fact that its power footprint is a 50% power reduction. And so a lot of the research that we're doing is on green ICT, and we have a sustainability program that in Ciena's case is second to none.
Any more questions? Okay.
All right.
Firstly, thank you.
Oh, that's excellent.
Thank you, Rod.
Thank you.
I think we can all take something away from this very eye-opening session today. Particularly interesting to learn about the emerging technology, since I'm not very techie, and the path they actually go down to become actual products that we all use today. 2024 is all about using curiosity. You talked about going beyond where we could ever go, and I thought that was very eye-opening as well. And of course, everyone in this room is and knows the importance of cybersecurity. So cybersecurity, and how the minister also mentioned the use of AI and how we can use it in collaboration. So personally loved the no harm, no foul, all about testing, experimentation, and the emphasis on that, I think, is so extremely important in eResearch and all of your teams. So thank you again for traveling halfway around the world to be here with us today. It was amazing to hear from you, and thank you again. Thank you. I hope you enjoy that.
Oh, absolutely.